In the early hours of April 3, 2026, an American F-15E Strike Eagle flying under the call sign Dude 44 was struck by a shoulder-fired missile over southern Iran. The pilot was rescued within hours, but the ejection left the Weapons System Officer, the WSO, stranded deep in hostile territory. Badly injured, he attempted to evade capture by climbing into a vast, jagged mountain terrain where natural rock formations block radio signals and stall physical movement. At the same time, Iranian Islamic Revolutionary Guard Corps troops mobilized across the region, scouring the mountains with a bounty on his head. The combination of a medical emergency, a complete radio silence, and an advancing enemy force created a scenario where conventional search and rescue logic no longer applied. Standard procedure involves saturating the area with low-flying drones or helicopters, but in this airspace, that approach would likely lead to further shootdowns. High-altitude visual and thermal cameras were also ineffective, as the deep ravines and rocky overhangs of the Iranian desert naturally mask human body heat and visual presence. 36 hours passed. With no radio contact or visual confirmation, the military had no data on the airman's location. The turning point came when the CIA relayed exact coordinates to Central Command. The agency bypassed visual sensors entirely, pinpointing the airman's location by measuring his heartbeat from 40 miles away. Identifying a specific pulse through miles of solid rock and desert air proved the U.S. had successfully deployed an operational quantum sensor. Remote heartbeat detection has existed in some form for over a decade. In 2013, NASA's Jet Propulsion Laboratory developed a disaster response tool called Finder. This system used microwave radar to penetrate rubble, measuring the physical movement of a victim's chest cavity as they breathed. Because it relied on physical wave reflections, Finder was limited to a maximum range of 100 feet. To achieve a 40-mile range, the CIA worked with Lockheed Martin's Skunk Works, the same division responsible for the U-2 and the SR-71 Blackbird. Their project, Ghost Murmur, moved past classical radar and into the field of quantum magnetometry. The core hardware of Ghost Murmur consists of synthetic diamonds engineered with nitrogen vacancy, or NV, centers. These microscopic defects trapped inside the synthetic diamond lattice act as highly advanced sensors with extreme sensitivity to magnetic fluctuations. These sensors detect the faint electromagnetic field generated by the electrical impulses of the human heart itself. Detecting this signature from 40 miles requires filtering through a massive volume of environmental interference. Artificial intelligence provides the bridge between this raw quantum data and the operator. The software processes the feed in real time, isolating the rhythmic signature of a heart by mathematically scrubbing away the electromagnetic noise of the atmosphere. Ghost Murmur functions by mathematically erasing the noise of the world until only a single rhythmic pulse remains. As soon as Ghost Murmur confirmed the coordinates, the military launched an immediate recovery mission. A 155 aircraft strike package entered Iranian airspace to provide the necessary cover for the extraction. Diversionary attacks hit 7 different locations simultaneously, drawing Iranian forces away from the airman's true position. 2 MC-130 Commando 2 aircraft landed on a dirt farm to retrieve the airman, completing the mission in minutes. The rescue proved that abstract quantum physics can now be used to locate and save personnel in a kinetic war zone. The success of the rescue moved quantum sensing from a controlled lab experiment to a verified, combat-ready reality. Traditional stealth technology relies on physical geometry and specialized materials to deflect or absorb classical radar waves. Quantum magnetometry ignores these physical defenses, as a vessel's shape does nothing to mask its inherent electromagnetic signature. Isolating a human heart from 40 miles away suggests that massive stealth bombers or submarines are now fully detectable to these sensors. This shift is currently driving a $2 billion market for quantum sensors and radar systems. By removing the advantage of physical concealment, this technology changes the fundamental calculus of military power. The Iran operation established a new baseline for detection, one where environmental noise can no longer be used as a shield.